Hello, hello.
Good morning, everyone, and welcome to this talk here. I'm Zhenya Liu, a program manager in Windows graphics team, and this is Priya, and also Vishal. So in this talk, we don't have any alcohol, but we still have fun here because Priya, Vishal, and I will show you how to play together in your games. And we'll show you how to enable multiplayer using the Wi-Fi Direct. And also, I will show you how to build a leaderboard to your games using Windows Azure mobile services. I love to play with my friends in my games because it's a lot more fun to play against real people compared to playing the best AI. And also, when you're playing with friends, you will know, hey, they actually no longer who they are in the games there. And when I talk to the game developers, they also love allowing gamers to play together in their games because it's all about reach here. When a gamer is playing with friends in their games, they refer to the friends, hey, now this is a new game, why not try it? And also, when they're playing against someone and cooperating with someone in your games, they spend just more time because they need to play with others, and also it's more likely to spend more money in your games. So that's about boosting the user base and also the game usage in your games there. Also, now we are seeing more and more portable Windows devices floating around, which means someone is more likely to always bring the devices. They want to play with their friends in the party, in the house, in the library, or just in the bus. So those are the new opportunities for the developers. Think about playing together in your games there. In this talk here, we'll show you several key scenarios about playing together in the games, and we'll also show you some turnkey solutions provided by Microsoft, and also show you how much more you can do using the same tools we illustrated today. We will basically split this talk into two halves. In the first half, Priya will show you how to use the proximity APIs to easily find and play with friends near you. In the second half, I will show you how to add a social backend using Windows Azure mobile service to your games. So now, Priya.
Great. Thanks so much for that introduction, Zhenya. My name is Priya Dandawati, and I'm a program manager at Microsoft in the networking team. Today, I'm going to talk to you a little bit about how easy it is to bake multiplayer gaming into your app. So we've actually built together an app for you, and it's called Critter Stomp, and I'm going to demo it here in just a few moments. And unfortunately, this app isn't available in the current build SDK sample, but it will be available by the time we ship. So look for it at that time. So the first thing I'll do is just switch these monitors so that you can see the app. First thing you'll see is that we're projecting Zhenya's PC over here and my PC over here. So that way you can see both sides of this multiplayer gaming experience. So I'm going to go ahead and launch the app. It's called Critter Stomp, and it's conceptually very similar to Whack-A-Mole. We're both going to try and stomp as many bugs as we can on the screen. So you can see initially we're prompted with the option to either stomp alone or stomp with friends. As Zhenya mentioned earlier, it's a lot more fun to play with your friends. So I'm going to go ahead and choose to stomp with friends.
And now we'll join the game.
Perfect. Then I'll host. And you can see without either one of us having to enter our game IDs or IP addresses, my PC was automatically able to find Zhenya's. So I'm going to go ahead and invite Zhenya by tapping on his name.
And immediately, I see Priya's name on my machine. Again, one single tap to accept the invitation.
Perfect. And now the games are getting connected. So what's going on in the background here is we're setting up an out-of-band Wi-Fi Direct connection. And so it looks like it's up to me to start the game. But that's how easy it was. It was 3 simple taps to get our games connected over Wi-Fi Direct. And we're off. I'm fairly bad at this game. Zhenya usually beats me, so I won't play for too long. Instead, I'll tell you about the data that we're sending across Wi-Fi Direct here. There's 2 important pieces of information. The first thing is the timestamp. The time is actually getting set on my machine and getting pushed over to Zhenya's. And that gives you a pretty good idea of the latency of Wi-Fi Direct. You can see the time is keeping pretty well in sync. The second thing we're sending across is the XY coordinates for each image, so it's displayed in the correct location. So it looks like I lost, which is no surprise. But I think we can play again. And while 2-player is interesting, I think 3-player could be even more. So I'd like to invite Vishal Matre, our developer working on Wi-Fi Direct, up here on stage. We're going to show you 3-player Critter Stomp.
Again, I join again.
Perfect. And it looks like Vishal's joining as well. And it looks like I can, and without anything different, we see both Vishal and Jenye's names displayed on the screen. So I'll invite Jenye. And next I'll invite Vishal. So you can see it's really, really simple, and the user experience is pretty much, we keep the user very informed about the state of the connection during this. Maybe running into a bit of interference here, given that we're using Wi-Fi Direct and using similar channels as the other Wi-Fi radios. So we may have to try this demo again in just a few minutes. Yeah, why don't we try this in just a few minutes again? So I'm going to go ahead and switch back to the presentation, and we'll come back to this in just a minute. So there's one more thing that we're going to show you once we get our machines set up again, and that's an even easier way to connect your machines together. And it's using another really cutting-edge technology called NFC, or near-field communication. And the nice thing about NFC is that it makes it really easy to express intent with your devices. So it's really easy to select something or someone. And what we do with NFC is we share our Wi-Fi Direct pairing information during the tap and set up an out-of-band connection as well. And you can bake this into your app really simply by adding one more call, and that way you can either browse and connect to nearby peers, or you can tap with their machines to connect to them. So let's talk a little bit about how you would build this into your app. The Proximity API lives in the windows.networking.proximity namespace. And we've got these little NFC stickers. We've got a whole stack of them up here that folks are more than welcome to, and these point directly to our APIs. So feel free to come up here and grab these before you leave. An important note, though, please don't stick these on your badges, because I think there's a conflict between the RFID tag in your badge and these. But you're welcome to grab as many as you'd like. Now, the appeals of Wi-Fi Direct is that it doesn't require an AP. So that means there's not an intermediary that's taking up or that's wasting your time in order to route messages. So it's a really fast connection. And we've built our APIs in such a way that Proximity will only discover the nearby players that are running your app in the foreground. So we've made it a very, very intentional API. Lastly, there's no need to deal with any IP addresses to get your games connected. It's really simple and easy. So I'd like to talk to you about the statistics about Wi-Fi Direct as well. It's a local peer-to-peer connection, and the average connection time takes between 3 to 10 seconds. In practice, we're seeing a throughput of 20 to 30 megabits per second, which is much faster than Bluetooth. Bluetooth gets about 2 to 3 megabits per second. And in latency, we're actually seeing 30 to 100 milliseconds. So what this leads to is a really high throughput, low latency connection, a really high quality connection for you to deliver high quality experiences on. And before we jump too deep into our API, I'd like to let you know that the way we built our API also leads to a very simple user experience. And I'll show you that in just 1 second. So this is the initial screen Jenye and I both saw to either join a game or host a game. And this is really important because essentially at this point in time, we declare our roles, our networking roles for the game. When I choose to join a game, that means I'm declaring myself as a client. And when I choose to host a game, it means I'm declaring myself as a host. We'll talk a little bit more about what Peer Finder is in just a moment. But what this leads to is a star topology for networking. So we've got one host connected to multiple clients. And the great thing about our API is that you can connect up to 5 clients. So that means you can really go crazy with an interactive, fun game. Another important note about this networking model is that this is relevant when dealing with error cases as well. So if the client loses connection, depending on your game logic, your game could just continue and not have it be a big deal. But if the host loses connection, it's really important to message that error to the user to let them know they have to reinitiate the game. So let's take a look at some of this code. On the left-hand side, you can see this is code from the host, and on the right is going to be code from the client. And we're going to parallel these concepts throughout the rest of the slides. So the Peer Finder object is what's going to help you find and connect to nearby players. Before calling peerfinder.start, you're going to declare your role and also register a few functions. So on the host side, we'll clearly declare our role as host and then also register the triggered connection state changed event, which is related to connecting via NFC. And on the client side, we're going to register ourselves as a client and also register a connection requested function. And the connection requested function will let us know when we receive an incoming connection from a host. And by calling peerfinder.start, it essentially broadcasts or advertises our Wi-Fi direct information onto the radio so nearby peers can find us. Now let's take a look at finding nearby players. So in this example for CritterStomp, the host searches for nearby clients, and it does so using a really simple call, which is peerfinder.findAllPeers async. And this returns a list of nearby players, and then we display that to the user. On the client side, we just wait to be found. And for the sake of simplicity, we've just made it so the host searches for nearby clients, but in your app, you could make this experience completely symmetrical so that the client searches for nearby hosts as well. So now I've found Jenye, and I'm going to go ahead and tap his name and invite him to play a game with me. So once I tap his name, we do a call called peerfinder.connectAsync and pass his information to the API. And what happens is we get a stream socket returned back to us. Windows takes care of setting up that stream socket for you, so all you have to do is wait until that socket is established. Lastly, we'll take that new peer and add it to a list of connected peers. There's one more element in here, is that while we're connecting the peers together, we are showing indeterminate progress using a progress bar. And it's really important to keep the user informed of the state of this connection. For the client side, we first receive the incoming connection through the connection requested function and display that to the user. Next, we'll use that exact same call, connectAsync, to connect the devices together once the client has accepted the incoming invitation. User consent is key. Lastly, this is a snapshot of a 3-person game. I'd like to draw your attention to the top right corner, where the host maintains a list of all the connected peers in the game. This is a really important UX element because then the host or game leader doesn't have to maintain a tally of who's connected to their game. And that's all it took to get our games connected via Browse and Connect. So let's take a look at how you would get your games connected via NFC or Tap and Connect. So the triggered connection state changed function has a couple different states that tell you about where the state of the connection is. There's peer found, which essentially means that we've discovered a nearby peer. There's completed, which means that the socket's been connected. And lastly, there's failed. So after a peer is found, we should display some type of indeterminate progress to the user. And next, once the peer is connected, we'll create a new socket and add that to our list of connected players. On the client side, we do the exact same thing. The only difference here is that once we've gotten a socket established, we navigate the client to a waiting for host page where we force them to wait until the host begins the game. And the last thing I'd like to show you is a really simple call for sending data back and forth. And in this example, it's the timer. So the host is setting the time every single time, and they'll decrement the counter by 1 second. And so they need to push this update to all the clients. So we use a really simple for each loop and push this new timestamp out to all the clients. And we use opcodes. In this case, the opcode is update client time. And on the client side, there are 2 function calls that we make. Read message, which essentially extracts the message from the incoming from the socket, and parse message, which goes through on a case-by-case basis looking to see which message it is or which opcode it is. So once we see that it's opcode update client time, we'll call the update client time function on the client side, and the time will decrement. And that's it. That's all it took to get our game connected and send messages across. So you can see it's incredibly simple to set up a multiplayer game in your app. So I'd like to talk to you about some UX considerations while you're building your app. First of all, it's really important to keep the user up to date on the state of the connection. The appeal of this technology is that it's incredibly magical, but at the same time, it's important that the user has high confidence that the right thing is going on. So for Critter Stomp, we use indeterminate progress UI as well as text on the screen indicating that we're waiting for the host or waiting for the client. It's great to use that in your app as well. Game terminology. We discussed the concepts of host-client networking model, and it's really important to translate this geeky, techie stuff into something that's meaningful to your game. So for Critter Stomp, we use concepts like game leader or challenger or player, and these really resonate with normal players. And lastly, handle your network failure cases. Once again, if the client gets disconnected, your game could potentially continue. But if the host gets disconnected, it's important to message that to the user. That said, from our own practice, we haven't seen a Wi-Fi direct connection fail once it's connected. But it could very well be that the client or host walks out of range of Wi-Fi direct, so it could potentially happen as well. Lastly, don't just stop at games. We've demoed Critter Stomp for you here today, but this is your opportunity to build a fun, creative app. There's lots of other use cases for the proximity APIs. For example, you could share videos back and forth, do some type of drag and drop app, collaborative drawing, painting, sketching, or even collaborative DJing. That's another application. Learning together, where the host could potentially be the professor and the client a set of students in a fun, interactive chalkboard session. And a few years back, we actually had an intern develop a multilingual chat room using the Wi-Fi Direct APIs, which would translate from one language into another. There's a lot of different applications, and this is your opportunity to make it fun and creative and interactive. So if there's one thing I'll leave you with, it's that the proximity APIs give you a quick and easy way to get your app connected. And Windows takes care of a lot of the complexity of getting you connected so you can focus on delivering a high-quality experience. So before I head off stage, I think we want to try that demo one more time. So once again, Jenye's PC is being displayed over here, and mine is over here.
And I'll join the game.
Perfect, so I'll host. Perfect, it looks like Jenye is all connected. Perfect, and looks like Vishal's connected. You can see now that the list is completely maintained at the top. And we're off, 3-person player. And once you guys get this app for yourselves, you'll be able to connect it up to 5 players. So you'll be able to kind of grab as many PCs as you'd like and see it for yourselves. It's unfortunate that I'm so bad at this game. And so once this finishes up, I'd like to go through the NFC tap as well to show you how easy it is to use NFC to connect your games. Great, so I'll choose the option to stomp with friends, and once again host a game. And instead of tapping Jenye's name on screen, I'm going to tap his PC. And I'm sure you heard a small in-range sound, which means that our games were, or the NFC radios were essentially in range with each other. And Windows does that so that you don't have to take care of the UX complexity of letting users know that, hey, the devices aren't in range or they are in range. And really simple, once again, actually NFC ended up being a little bit simpler than Browse and Connect. But you can see how easy it was for us to express intent with our devices using NFC. Great. Perfect. So with that, I'm going to hand this presentation back over to Jenye for him to talk to you a little bit more about Windows Azure mobile services.
Okay, thank you. Wow, it's really impressive. It's just single 2 taps, or maybe just 1 tap. Now you can connect with others. So I still remember back in my college days, my roommates always keep jumping up and down and yelling in the hallway, hey, what is your IP address? And I think you may have some similar experience. So, but now I can tell you, your gamers no longer need to yell again. So they just need a simple tap, and then they can play with each other easily using the games there. So now the first part is about how to connect and play with the games online. But also, for a lot of games, we want some offline social backend service so that you can better engage and check your gamers, something like leaderboards, achievements, and so on. So in this talk, I will show you how to build a social backend using Windows Azure mobile services. So when we are talking about social backends, developers coming from the console community will think about Xbox Live. But we also witness a lot more and more developers are picking up Windows Azure mobile services to build a social backend to their games because they want different development experience, they want different user experience, or they want better cross-platform support there. So in this talk, we will focus on Windows Azure mobile services, and we'll show you how you can do that using the simple tools we showed up here. Before we dive into technical details, let me first show you a game example to show what the end-user experience will look like. So this is a simple game. The first page allows me to log in using my Microsoft account here. So I just click, and you will see there is this simple login page showing up here. So I just log in. Now connected. And then next it asks me for my game tag. We are ready to play. We already logged in and ready to play here. So this is a simple game that asks me several questions to help me prepare for the next National Geography B competition. So I keep doing it again and again. And tallest waterfall, the Angel Falls. Largest ocean will be Pacific. Largest continent will be Asia. Ooh, done. I get all of them, and you see a toast popping up on the top right corner. And you see your rank is #1. And also you can see the leaderboard here with my name. I'm the top scorer in this game here. And also the other 4 top scorers. Then that's the leaderboard you will see in the game. If you go back to your screen and look at this live tiles, it pop up. Because now you're the #1 in the leaderboard here. So in this game here, all the scenarios kind of look familiar to you. We talk about leaderboards. We talk about ID logins. We talk about a lifetime push notification here. In order to add those capabilities to your games, you need to tackle a few problems here. How to authenticate the users so that you can know them and remember them. How to build and maintain a leaderboard in your game. And how to send out the push notifications using either live types or toast as we've shown here. What we've shown here is that Windows Azure Mobile Service can help you easily to do all of those easily. It provides a wide range of capabilities you can pick up, you can add to your games here. Cloud storage, you can maintain a database on the cloud and you can easily manipulate with them. It allows users to log in with some popular identity providers, including Microsoft accounts, Facebook, Twitter, and Google accounts. It also helps you to send out notifications natively to different platforms. We're talking about live tiles on Windows and Windows Phone. You can also do the same thing using on the iOS and Android platforms. Windows Azure Mobile Services could help you achieve all these scenarios, but we also have other options of why you should consider Windows Azure Mobile Services. Because it provides a backend service that you can easily pick up and add to your games. That's what I'm going to show you in the next 10 minutes. And also, it provides native SDKs on Windows, Windows platform, iOS, Android, web, and HTML5, which means now you can develop and deploy that services for your game on almost every single tablet and machines on Earth here. Microsoft just announced the GA for Windows Azure Mobile Services yesterday, which means now you can enjoy the high availability. No matter where you're deploying and developing your games, your gamers could be connected to a data center that's close to him. And also, as you and your game grows, you can easily scale up your backend on the Windows Azure Mobile Services. In the next 10 minutes, I will show you how to easily add the leaderboard, login, and the push notification in your games here. To speed things up a bit, I already created and registered a game with the Windows Store. I already signed up for Windows Azure Mobile Services, and I already created and connect the first mobile services there. And if you want more technical details about that, we have other options dedicated for Azure Mobile Services and how to interact with them and how to play with them. And this talk will focus more on the, hey, what kind of scenarios it enables you to do, and what's the concept and basic step you need to go through in order to add that to your games here. First, let's talk about adding leaderboard to your game. So in order to create a leaderboard, you need to first work on the server side to set up a database and also the scripts to manipulate this database. Also, you need to set up the client side so that you can add the necessary code to insert the new data and retrieve the data from server. And last but not least, connect the server side and the client side together here. First, about setting up the server side. You need to first create a table to maintain the data you need to manipulate. So table is a database on the Azure mobile services that you can create and you can store data, and automatically it will provide 4 default behaviors for you: how to insert data, how to update data, how to delete data, and how to read the data from the database there. And we already provided default scripts for you to do this the right thing. So for this particular demo, I need to create a table for the result, which we will remember, hey, after I play this round, how well I'm doing, and what's the name, and that information. We also need another table to maintain a leaderboard. Hey, who is the top scorer? What's the position? What's the overall score for that top scorer there? After we create the tables, now we have 4 default scripts to help you insert, upload, update, delete, and read the data. One powerful thing from Azure Mobile Services is that it allows you to customize those scripts so that you can do a bit more than the default. Say, for example, this is the updated insert script for results. It automatically inserts the new data from the client code to the database. But at the end of this script here, you can also trigger a new script on the server side, here called update leaderboard, so that after it inserts the data in a new row of data to the database, it will automatically switch to the next operation to update all the scores and names on the leaderboard. And then it will trigger yet another script to actually reorder everything on the leaderboard, so that now after a new result is inserted, you can have the new rank for each player. So as you can see here, by updating the server-side script, you can trigger a cascade of operation and do the right thing, and everything will be done on the server side so that you don't need to worry about security, performance, and anything, and the Azure Mobile Services server will take care of that for you. So now you already set up your server. Let's come back to the client code. In the client code, you need to do 2 things in this demo here. One is when you collect the score, the new score from the player, you just code insert async to insert that new row of data to the database so that it will trigger the update of the table and also update of the new position of the leaderboard. After the insert new data, the next step would be, hey, now the leaderboard is updated. Let me pull the data from the leaderboard so that I could show you at the end of the game to the players here. And that's, you can easily retrieve the information from the table here, and then to enumerate all the information and show that to the gamers. So you just need to set up the tables and scripts properly on the server and set up the client code in your game. And that's all you need to do to add a leaderboard to your games. Next is about adding authentication to your games. So in order to be able to authenticate the gamers here, again, you need to set up properly the server side and then add the code to the client side and connect them together. So here, we just use Microsoft account provider as an example, but actually you can also talk to the Facebook account provider, Twitter, and Google account provider in a very similar way. After we register for the Live Connect service here, we need to provide the name of my game so they remember what game is actually calling this live service. The most important pieces here is that there are 2 pieces of a string here. One is called the client ID, and one is called the client secret. Those are the 2 keys your Azure Mobile Services could talk to the Live Connect service so that they could exchange information about your identity. In order to connect the Live Connect service and your Azure Mobile Service, you just need to simply copy these 2 strings and paste in the web portal of your Azure Mobile Services under the identity. And just copy-paste that client ID and client secret. After you've done that, they are talking to each other and they know each other. And if you're registering for Facebook, Google, or Twitter, do the same thing and copy-paste the secret strings also under the Facebook settings, for example, as you can see here. So now the Live Connect service is talking to the Azure mobile service. We need to add some client code. And the client code is exactly one line of code. You just call login async and also tell them, hey, I want to use Microsoft account to authenticate this user. When the game executes this line of code, you will see a very unified user login page to ask your gamers to log in with their account name and password. And Azure Mobile Services will take care of all the backend discussion with the Live Connect service. And after this code, if it succeeds, your game will get a token that can uniquely identify this gamer. And if something wrong, say I canceled my registration or the password is wrong, the end user will also get an error message, and then your app could continue to handle that error there. So that's how you add authentication capability to your games here. But I want to show you one more thing here. Remember, each time you create a new table, the four default behavior you can do for each users in your games. So reading, adding, reading, updating, and deleting. You can actually change the data permission of those 4 operations. Instead of, hey, anyone, this time I would choose, say, only authenticated users could insert a new data to the table, which means each time Azure receives a new request to insert the table, it will automatically check whether this user is actually authenticated. And if yes, I will allow you to proceed. And if no, I will automatically say, hey, this is not, I don't recognize this user. I will not do anything in this table here. So by doing this operation here, the Azure mobile services are actually taking care of the authentication on the server side for all subsequent operations. And you developers don't need to worry about that, because just ask Azure to do that, and Azure will take care of the authentication. And that would be a big relief for developers, so you can focus on the game logic, not some authentication checking like this one. Last, I'm going to talk about push notifications. And that's a very unique and efficient way for developers to talk to the gamers and also to communicate between the gamers on your platform. In order to add a push notification, you need to register and connect to the Live Connect service. And also, in order for the Live Connect service to know which device to actually send out this message, you need to create and also store a channel so that you need to know, hey, which device I send out this push notification. And ultimately, you need to update your server-side script a bit to actually send out that push notification. We already registered for the Live Connect service in the previous scenario, so next is how to actually connect it with my app here. If you go to your dev center under the Windows Store, you see your game here, and also there's a big block called services that encapsulates all the information related to services like the push notification. If you enter that service, you will actually see yet another 2 key secret strings. One is called the package security ID, and the other one is called the client ID. So you just copy these 2 strings back to your Azure mobile services under a new tab called push. You just copy there, and then now the Azure mobile services are talking to the Live Connect service in terms of the push notification, and they know who is responsible for what. Next is to acquire and store channels. In this simple game here, each time I complete a round of games, I will send myself a new toast and to update the live tiles on my device. So each time I launch a game and after a gamer is logged in, I will create a push notification channel. And then each time I send out a new row of data, including my name and result to the cloud, I will also include that channel, the URI of that channel, to the database. So now the Azure mobile services know, hey, what is the channel I need to send out to the push notification? And the last thing we need to do is to actually update the script to send out that notification. Remember, we have a cascade of operations in the insert script. Each time I insert the new data, it will do the insertion and also trigger the update of the leaderboard. Now we will append yet another operation at to the end of that cascade called a send notification here. And actually, you need just one simple line of code, push .wns, send toast text. And that's all you need to send out a push notification from the Azure mobile services using the channel you just stored. Similarly, you can do the live tiles using send tile square block. And you can send out the information to update the live tiles on the gamer's tablet. In the past 10 minutes, I quickly show you how you can easily add leaderboards, ID and login, and live tiles to your games. But actually, you can do more using the basic tools we illustrated here. Think about achievements. It's just yet another table you need to maintain and manipulate in your games there. Also, once you identify your user, you can easily store his preference or skill set to the cloud, so that next time he switches to the next device, you can easily put all those information to that new device after authentication, so that he could easily consume and keep going in his games there. Live times and toast notifications are very similar to each other, and we've already shown you that. But wait, we can do even more compared to what we showed here. Let's think about matchmaking. How are you going to use the Windows Azure mobile services we just showed you here to do the matchmaking? You need to authenticate your user to allow them to to log in with their ID so that you can recognize them. You need different tables to store information about this user, say preferences, game settings, skill set, or game status. You also need to add the table, say geolocation, or what kind of place I would like to play with, or what mood you're in now. With all those information here, you can easily do the matchmaking on your server side because you already know, and you already know who they are and what they want to play and whether or not they would like to play with others. Yet another scenario, turn-based gaming. I'm playing chess or diplomacy games with others. How are we going to enable that scenario? Again, you need to allow the end users to log in so that you can recognize them. Again, you need to set up the database in the cloud so that you can remember, hey, where are the pieces, where they are, whose turn it is now, how much time you left, that kind of information. So what happened, this is a diplomacy game, which each round will take sometimes 24 hours when playing with a friend remotely. How do I let him know that, hey, I just moved my pieces, now it's your turn? Remember, we have the push notification. Each time I'm done with my round, the game will send a push notification to the other opponent. Hey, now it's your turn. You have 24 hours to respawn. By combining both the authentication, storage, and push notification, you can easily add the turn-based gaming scenario to your games there. So far, we show you how to set up the server-side scripts and tables using the web portal, and that's applicable to any platform, any browser that you use. If you want command line tools, we also have command line tools for you that will help you automate the creation, verification, deletion process of a mobile service. So if you are an admin, you want to repeatedly deploy something, or you want to pass the work to the next guy, command line tools will be your best friend here, and it's available on both Windows, Linux, and Mac platforms. If you are developing Windows games using Visual Studio, things are even easier for you because we provide integrated support in Visual Studio. In the keynote yesterday, we already give you an overview of what's going on in the Visual Studio and what's integrated here. The two things we want to highlight here. One is called the Server Explorer, as you can see on the left part of your Visual Studio. It will allow you easily to see what kind of service you already set up, and under each service, what table you have, and what script is attached to this table. The best thing is that you can not only read them, and actually you can update them, and once you hit F5 to deploy that, everything will be synced with the server. So you can combine everything into one single box, and Visual Studio will be a one-stop shop to deploy and develop the Windows Azure mobile services. And also, Visual Studio provides a wizard to help you easily add push notification into your game. So just a few single clicks, you're done, and all the codes are there, and you can forget about it, and you enjoy the benefit of push notification in your games there. Windows Azure Mobile Services provide a pre-configured backend you can easily pick up and add to your game, so that you can really focus on the game contents and game logic, not the services itself. So all in all, in this talk, we show you how to enable the gamers to play together in your games there. Priya showed you how to allow your gamers to easily find and connect with people nearby using proximity APIs. And I showed you how to add social backends to your games using Windows Azure Mobile Services. More importantly, with the tools we illustrate here in the past 40 minutes, you can do more in your games, and you can cover a lot more other scenarios and make more fun for gamers here. And I hope you enjoy all these tools here, and don't limit your imagination and creativity with the tools with here. And actually, you can do more, and you could have more fun for your gamers. And if you want more details about Azure Mobile Services and best practice, we have several talks after this one. You can go and keep learning from the Azure Mobile Services here. And we hope you enjoyed the talk here. Priya, Vishal, and I are ready to take your questions.